This screencast is about migrating data from Azure Blob storage into Cosmos DB. So the first thing, let's take a look at the data inside the Blob storage. So this is my Blob storage account, and here I kept some data in the blobs. In this container data, I have a CSV file which is having my data. So the CSV file, here it is. It has some commodity name and commodity code, class name, etc. And you can get this example data from this site called catalog.data.gov. So they have a lot of different data sets. So from here, I picked up one of the data sets and put it in my blob storage. It's a CSV file. And now we will move it into Cosmos DB using Azure Data Factory. Okay, now we come to our Azure Data Factory instance. You can get this instance by clicking on this create a resource and then just choose Azure Data Factory, give the name, choose the version, and that's it. It will create an instance for you. So you come to your Data Factory instance in Azure and then click Author and Monitor. So once you click on this, you will come to this screen. So now let's choose here copy data. So that's what we want to do. We want to copy from Azure Blob Storage to Cosmos DB. Now give the task name Blob to Cosmos DB and then click Next. Now let's choose the source connection. So here I can go and click create a new connection, and you can see there are a lot of different options are there, but now we are interested in this Azure Blob Storage. Click continue. Okay, here's the name we have to give. Let's choose the name. So this screen is very simple. It's just asking a couple of things, how to connect to your blob storage, and you can give this account key, and for that there are a couple of other ways, like you can use the subscription or you can manually type your key. So this is it. It's very simple. I just chose my subscription. Azure subscription, gave my storage account, and that's it. And now the Data Factory will be able to connect to my storage, and you can test this connection here. You have a couple of other options, like you can get the keys from the key vault. That's the recommended way when you're coding, that always get the keys from the key vault. Never have your connection in the code or even in any config file. So here, let's go and test the connection. Okay, my connection is successful, and here is my source name, Azure Blob Storage, and I can click finish. So a couple of other things. This connect via integration runtime, we have to leave it auto resolve integration runtime because we are running everything into the Azure itself, so we don't have to do here anything. But if you have a system which you are trying to connect with your on-prem, then you may need to do all this, like self-hosted. So integration runtime setup. We don't have to do that because everything is in Azure for us. And the second is authentication method. We are using the account key. This is the simplest way, so I can connect to my Azure storage. But if you have some other application or other things you're running, like you have a managed service identity, if you have app which is running and it has its own identity, service principal, all those things you can give here. Or if you have a SaaS URI, you can use that. But for us in this test, we'll just use account key. Look here, when you choose managed service identity, you have to give the service endpoint, which is basically a service running which have an identity and have a permission to connect to your storage account to get the data. So let's keep it simple for this one and just use the account key, and that's about it. Okay, now click finish, and then we are out of this. So we have set up the source data, which is Azure Blob Storage, and next is where are my files kept. So if I just give, as you know, our files were here in a data container in my blob storage, and it's called data CSV. So I can go ahead and choose my container, which is data. And now If I am trying to copy all the files inside the container, I will just click here, copy file recursively, but I'm not interested in copying all the files. I want to copy a particular file called data.csv. So here, as you can see, there's an option that you can just copy the whole binary copy from, source to destination, but we have a CSV file, so I'm not going to check this because I want the CSV file moved as a JSON in the Cosmos DB collection. So here, compression type, again, I'm going to leave it none, but just know that Azure Data Factory can deal with compressed file. It can zip and unzip your files from source into destination. So next, now we are talking about how to format our data. As you can see, we chose the text format. Column delimiter is comma. Now it is showing me the preview of my file. So it looks like everything is good because I can see the preview here. And now you can see the schema. This is auto inferred by the data factory. As you can see, it is taking each and every column name and figuring out what type it is. Segment name is string, family is int64 and all that. I will leave everything because the data factory has done a great job. It inferred all my column names properly. And then I'll just say next. Now I have to choose the destination source name. For destination, I will go here and choose Cosmos DB. Continue. Let's change the name, Cosmos DB. And same thing again as before, we'll just give the use the subscription to get the account name and the database name. So it's very simple. Let's just do that. So here I just chose my subscription, got my account name and the database name. Let's go and check the connection. It's working. Finish. So far here, as you can see, I just chose the database name. Which collection the data should go in will come on the next screen. Now let's do the next. As you can see, it's figured it out. My source is blob storage. Destination, now this is where we will choosing the collection. So my collection is IoT. So I will skip column mapping and then just say next. So here, as you can see, some sync properties, they're talking about what is my separator. And my behavior is right behavior is insert. If you are updating or if the data is already there, sometimes you want to update, then you can choose this upsert, but just let's keep insert because I'm trying to move all my data from blob storage to Cosmos DB. Right batch size, I will leave it as is. We will come back to it and see how these numbers makes a difference. And then I'll say next. Everything looks okay. I will just choose here and say skip incompatible rows. Otherwise you can log also, but for this demo purpose I'll just skip, and I don't need a staging also. Here in advanced setting I have two values, data integration unit. I'm leaving this as an auto, and degree of copy parallelism means how many threads will run for each integration unit. Again, I'm leaving them as auto. We'll come back to this and see how we can play with these numbers to make our copying process more efficient. So just leave it as default, say next. And here's the summary. The data is moving from storage to collection. And we'll just say next. And it's deploying. Now let's go and look at what's happening. So while this process is running, let's go and check if the data is coming in my collection or not. Here, my database is IoT. Here's my collection. And if I click, I do see the data is start coming in with all the proper name of my columns. So that's all we have done so far. And let's go and see how we are doing at the copy process. So now we are seeing this copy process still keep on going, and it's been 4 minutes and it's just 11 MB. So something is wrong. It's taking awfully long time to copy all this data. So let's stop this thing and see what is the problem and how we can improve this whole process. Let's go to check our collection here, and I can see the data here, but if I go and look at the metrics here, so here in metrics I want to check the throughput. So I'm seeing my throughput is some activities happening there, but then same time I'm seeing a lot of throttling is happening. 429 number of requests exceeded capacity. So this, I shouldn't see anything here. That shouldn't be any throttling, shouldn't be happening. And then you can filter it out to particular collection if you want to see how your collection is behaving. So once you filter it out, you see the graph is still as is and throttling is happening. So that's not a good sign. So we're going to fix that and then quickly check the storage before we move from this screen. Choose this collection. So on this page, we can see the storage consumption for this collection. And I'm more interested in seeing how my data is divided into different partition. It is not equal, but it's okay. I can live with it. It is still using different partition, but let's go and fix our first thing because we are getting big time throttle. And that's why I think this whole thing is so slow. So you come to Data Explorer, Scale and Setting, and I'm seeing my throughput RU is just 1000. And that may be the problem, that I had spent so much time, more than 3 minutes, and still my copy job was not complete. So let's increase this to 10,000, save it. And let's go and run our job again and see what will happen. So last time I think we went beyond 3 minutes, which is pretty bad. Should happen much earlier and faster. We are starting our next job. Okay, so this job finished in 3 minutes 22 seconds. And data is total, I think, 11 MB. So it's not too much. So 322 is too much time. So let's see what else we can do. I'm sure still we are getting throttle. So let's check that first. So I can see I'm still getting throttle here. So let's bump up our RU again for the collection because we want this job to finish quickly. And the beauty of Cosmos DB is you can bump this RU, do this job. Once it's finished, you can take it down. And you can I'm doing here manually because I'm trying to show you demo, but you can do this programmatically also. That's like 2 lines of code to make the RU change go up and down. So I'm going to the max 50,000 RU and let's see how my copy task will perform now. So I'll go and restart. Okay, so this job finished in now 50 seconds. So you see how the RU of your collection will affect this copy job. Now let's see if we can play with some more variable to make it better. So it's a 50 seconds. Let's go and edit our copy job. Here's my pipeline. I click on this and then here is my settings. So see this data integration unit. Let's see if I take it to max 16 and 4 and then just do this, publish all. So you have to play with these numbers, change these numbers and run the job to find out what is the sweet spot, how many data integration unit and how many parallel threads you need for your job to run most efficiently. Now we made that change. Now let's run again and let's see if we can improve this. Okay, so this job finished and it still took 50 seconds. So changing the settings did not help much. But now let's see one more thing we can optimize it, make it a little better. Because if I see this collection and here if I go to metrics, click on storage. So here I'm seeing that my data is, few of the partitions are taking too much load and the other partitions are not taking enough load. So looks like my partition key is not set properly. So how I can find that out? If you see here in this collection of IoT, here are the documents. So see what I am seeing here, that my primary key is defined as PK and it is empty. So this is one mistake which we have made. The data is not partitioned properly. And I believe this commodity and the commodity name, this number can be a good partition key for me. And if I make a partition and just leave all the values default and then run this job again and then see whether that will make any improvement. I have another collection where I have created a partition key commodity, and now I'm going to increase this throughput again to 50,000. Put the TTL to 120 seconds so we can come back and see the data and save. Let's go back to our data factory and change our IoT to IoT2. Edit this. Here's the sync, and let's go edit the sync. Collection name. See, it was IoT. Now I'm going to change it to IoT2 and just publish it. And meanwhile, I can go and see in IoT2, it's all empty. There's nothing. What we have done, we have just created with 50,000 throughput and gave a proper partition key. So hopefully we'll see our data is partitioned nicely now. Now, once it's published, okay, it seems it's published. Now let's go back and run the job again. The last job took 1 minute 5 seconds. So it was 50 seconds, and now let's see with this proper partition key and 50,000 RU how this will behave. Okay, so this job finished and we did make a lot of improvement. Now it is 35 seconds. Let's play with one more number. Let's see if we can improve this a little bit more. Go back to our job. Here, click on this. So get the settings. Remember we changed this to 16. Let's go back to put it auto. We don't need to do this change, I believe, because now we have a proper partition key and publish all. And my RU is 50,000 also. So I should be good. While this job is getting published, let's check our collection. IoT2, how's my documents look here? So my documents are here, and you see now I have a proper partition key here, commodity, and I can see the proper numbers here. Okay, let's just double check one more thing, which is the metrics and throttling. So I'm choosing now the collection as IoT2, and there's no throttling. So this is beautiful. This is what you want. So IoT2 is running without any throttling. Okay, so now let's go back to the data factory and run it one more time. So our best performance is so far 35 seconds. So far the changes which we have done is created another collection with a proper partition key, gave the RU 50,000 RU, and put the number of instance and number of threads auto. So these are the few changes which we have done. Now let's refresh it. 35 seconds, 34 seconds. So we did improve to 34 seconds. Okay, one last change I want to do my settings. Here I will go data integration unit, go to 64 here, and maybe number of threads. I want to go 16. I'm trying to play with these numbers to see if I can squeeze performance out of all this. Now publish this. But you understand this, when you have data integration unit a very high number that may cost you more. And then if you have lot of parallel threads, so sometime having too much of parallelization can negatively affect your performance. So this is something you have to play with to get to the right number. But let's see, can we improve this? Okay, looks like we improved by 1 second. So here, not exactly, we did not improve anything. So it's still taking 34 seconds. This is it, but let me quickly check one more thing about our collection. That is there any throttling happening? There is a throttling happening. So as you can see, if I want to go beyond 50,000, I can go increase more of my RU and go, oh, sorry, I'm seeing this throttling because of this old collection. I should choose my new collection because, old collection we ran with different numbers. Okay, so you see what's happening here. Even with my new collection with 50,000 RU, still I'm hitting the throttling. Why? Because I increased the number of threads and number of instances to very high, which is not able to support this. So these are the few numbers you can play with, increase your RU so you don't have a throttling, and then increase number of instances and thread on the data factory side so you can have a very, very performant system. So looks like I cannot see my partition because the data is little delayed. But anyway, I wanted to see if all my data is partitioned equally in all the partition or not. This is it. I hope you learned something here, and now you know what are the variables you can play with, changing the RU and changing number of instances. We move 3-minute 22-second job to 34-second, and I believe you can squeeze more performance out of this if you will try it out with different number of instances and threads. So that's it for now, and let me know what other migration projects you want to see. Leave a comment and we'll try to make a screencast on it.